So hi, today the main topic is the wait, hold on. Uh, Today the main topic is the B tree. Uh, those of people don't know about B tree, or or those of people who just already have experience of watching my videos of like B tree thing is the B tree is kind of really is is kind of really that is hard to understand. It is the algorithm data structure part, but also it's informing that this how you do it. If there's some kind of the algorithm has a limitation of it, because like Bit3 it doesn't it is data structure and algorithm, but I believe it is data structure more advanced of the data structure, but it's kind of like it's like related to data structure algorithm because the B3 is it doesn't really kind of BFS a DFS thing. It's kind of extends version of the binary tree. Since binary tree, if there's like node here, and if it's three, the if the, the value the smaller value go left and bigger value go right, and the tree can have sip tree can have children um which is can have two children. So back again, um, well also there's a B tree and B tree there's a binary tree. This tree can have two children, so but it can only have a one children. But that kind of lead into the problem that if there's like only if this kind of case repetitive and if this going so far, this could lead into the problem that the time complexity of this is actually O and square. So this is kind of why we have to think about on the balance tree because binary tree can had some kind of like the children, but there's only one children. If there's a lot of one children, but that cause that's cause of like it just seems like already if there's like only one children of it, there's no other balanced children, and that was kind of problem and that we face. But also the problem was the kind of B tree thing is actually used in DB indexing part. The DB indexing is to make it to simplify DB indexing, you have to understand record. So what is record? So record is some kind of data unit that you define. Example, if there's a Pokemon, there's like Pokemonster here. So Pokemonster can have some kind of data. Example ID, their own unique value, or the name. Example Pikachu or Raichu or whatever stuff, and the gender and whatever stuff. And this ID part in the record is a unique value, so each is called key of it, record key. And the index file, DB index file, is just the gathers the whole of the record keys and it just make it into file, and it has the metadata of the real record keys, record value of that corresponding key, because the database you have to search for it, right? And now DB indexing, and it has to be fast because the DB indexing is basically trying to find your targeted records or a single record or lots of records. And when you do the DB indexing part, and going since reading at the it doesn't reading on the RAM because it is stored in the disk, so operating in disk is slower than the RAM because in the RAM there's a N1 cache or 2 cache for that, but example there's also TRB for it, and those kind of caching strategy and even the memory caching strategy is enabled in the memory RAM, but and also there's also data bus and address bus and control signal bus to integrate those signals to get the address or target value with the RAM, but the this there's no such thing as directly in the CPU. So we have to make it really fast. So to solve this kind of problem, we make in B tree. So it's kind of really from the binary tree and the B tree. B tree is kind of enhanced version of it. And B-tree, the time complex is always O(n) because it make consistent of the balance. Whatever it does, that there is balance. More you have, more minimum degree of it, the more you have, more reduce the height of the tree. So that's kind of really good. But however, the bit tree is kind of really bad when it does when you do the range operation, range serve or search operation, because there's no optimization for the range operation in the bit tree, because it's basically O n plus k. So because whatever you do is O(n), the certain one record key, but however, since this k equals to the range, the time complex is the O(n) plus k, so that's gonna be really some kind of time complex problem. So to reduce, to solve this issue, we now find out that there's more better algorithm data structure, which is called the B plus tree. But first they use, I don't know them, they use node linked list. Yeah, I think they use node linked list. So that's kind of a thing of like bit tree. So that's kind of why we have to learn it. Um, Actually, I have my repo of implementing Bittree. I actually trying to implement the database applications, but it's still ongoing because I'm launching our, we have our base launching service, and we have to make that first, and next part is on my side project, which is called the database application of it. So that's kind of the thing here. So I put some kind of all of the comments here, and I put all the explanation of this part. So this kind of this is it. If you have interesting about my side project, you can just go to link it here. So have a nice day. See you next time. Bye bye.